Small spherical packets of liquid water are called droplets. When it rains, raindrops fall from the sky and will often collide with other surfaces such as a window. The droplets may persist on the surface or slide down slower than their freely falling speed. Perhaps a droplet will combine with other droplets along their descending path, altering the speed of the newly formed packet. What holds these droplets together? Why do droplets behave as they do when they are in contact with surfaces? A droplet of water can be viewed as a medicine dropper creates it. Water sticks to the glass dropper as the droplet is formed. After the droplet becomes a certain size, the medicine dropper no longer supports its weight and it falls. The droplet, upon hitting a solid surface such as a tile, will form a splash pattern, and the water will be divided into smaller parts. The smaller the packet of water, the more difficult it proves to divide it.
The smallest amount of water is one molecule, made from 2 hydrogen atoms and 1 oxygen atom. One molecule of water is not directly observable with the human eye. A typical water droplet will consist of a large number of water molecules.
Droplets of water may not all be the same size, but if the conditions for creating them are the same, each new droplet will be similar to the previous one. The effect of different temperature water on the size of droplets formed is demonstrated by 2 paper cups with pinpricks in their bases. Water within one cup is cold and water within the other cup is warm. The cold water has been colored with a few drops of blue food coloring, and the warm water has been colored with the same number of red food coloring drops. The speed at which water empties from the paper cup and the number of droplets gives an indication as to the size of the droplets. It is discovered by observation that hot water has smaller droplets and a slower drip speed, ensuring that less water empties from its cup. The surface upon which a water droplet is placed affects its shape and ease of movement. Water droplets behave differently upon different coatings applied to the skin. Petroleum jelly, zinc cream, and olive oil are each applied to the skin, and a droplet of water is placed on each coating. The shape of the droplet is different on each of the surfaces, and the shape is indicative of how well the droplet sticks to the surfaces onto which it is placed. Water will run right off olive oil when the skin is turned to an angle, but water will stick more strongly to zinc cream than to the skin itself. An appropriate test for the attraction of water to a substance may involve the application of the substance to a flat surface such as a tile wrapped in non-stick cooking paper. After a droplet of water is applied to each, the tile is tilted until each of the droplets begins to slide down the slope. The presence of an object applied to a droplet of water will change its shape. A toothpick held just above a droplet will be attractive to the droplet, and attractive forces will ensure that the new shape incorporates the area of the toothpick which is in contact. A droplet of water placed on some non-stick cooking paper can be moved when enough of the toothpick is in contact with the droplet. When 2 droplets of water are brought together, they quickly combine, forming a larger droplet, and the toothpick can be removed from this final production quickly, creating a semi-spherical shape. Whilst a toothpick may be removed from a droplet of water, a piece of absorbent paper will irretrievably destroy the droplet. Attractive forces of water will also cause paintbrush bristles to draw together when a paintbrush is dipped into water, where normally the bristles have no attraction to each other. Whilst 2 glass microscope slides also show no attraction to each other and are easy to pull apart, Placing a droplet of water in between the slides and pressing them together makes the wet microscope slides comparatively more difficult to pull apart. Scotchgard is a waterproofing substance that is hydrophobic, meaning that water is not significantly attracted to it. 2 glasses may be set up, with 1 ply of tissue paper placed over the top and rubber bands used to secure each. Scotchgard, when sprayed over a single ply tissue, makes it capable of holding more water than an untreated tissue. An untreated tissue becomes wet and allows water to pass through, whereas a treated tissue will hold quite a large amount of water until the structural integrity of the tissue is breached.
Several observations can be made about water based on these droplet experiments. Liquid water is attracted to its own molecules, forming droplets, which means that it has cohesive forces acting on its molecules. Water is attracted to many other substances as well as to itself, like to a glass dropper, window pane, a toothpick, or to the skin and to zinc cream with varied strengths. When a liquid is attracted to another substance, adhesive forces act between molecules, which is described as the wetting of the substance by the liquid. Temperature and the type of substances interacting affect the strength of these forces.